Yesterday, we began adding and subtracting rational expressions, and we're going to continue with that today. Most of the fractions yesterday in our rational expressions were pretty straightforward. They're going to get more complex today. The biggest thing that you need to remember today is that it's important to factor the denominator in a rational expression before you begin to add or subtract. And you'll see why when we get into some questions here, but if you do not factor first, you're going to end up with a really messy situation, a gobbledygook that you need to deal with. And if you get something really ugly looking, chances are you need to stop, go back and see if you could factor first. So what we're going to do is we're going to start with example B first of all. So the first thing we're going to do in each of these denominators is we're going to take out a common factor. So on the left side we can take out a common factor of 5 and we're left with x plus 1. And on the right side we can take out a common factor of 2 and we're left with x plus 1. So you're going to notice that we have some similar factors here. Now, once you've taken out the common factor, before you cancel anything, before you try to find a common denominator, you should state your restrictions. In this case, if we take x plus 1 and equate it to 0, we're going to get x cannot equal negative 1 as our restriction. Now, when we come up with our common denominator here, since x plus 1 is in both of the denominators, it's already common. So we only have to use x plus 1 once. But 5 times 2 is 10. Now, what did I have to multiply the denominator on the left side to give me 10? Well, I had to times it by 2. So I have to multiply the numerator by 2. Same thing on the right side. I had to times this denominator by 5. So I multiply the numerator by 5 and I get 15. So when I add this together, 8 plus 15 gives me 23 over 10 x plus 1. So there's our answer in simplest form, and we have our restrictions stated up here. Second example, you cannot take out a common factor in the first set of factors, but you can take out a common factor of x in the second one. So now when we go to come up with our, before we come up with our common denominator, we need to do our restrictions. X squared cannot equal 0. So that also means x cannot equal 0. If you take x plus 2 and equate it to 0 and solve for x, we get x cannot equal negative 2 as another restriction. Now, what's our common denominator going to be? Well, it's going to be x squared times x plus 2. And most people are going to go, well, how did you come up with that? Well, first of all, I looked at the first denominator and I said, oh, there's an x squared. So I've got to have an x squared in each of my denominators. Then I went to the second denominator and I saw, oh, there's an x. But if you think of what x squared means, it means x times x. So we actually have x as part of our common denominator already. And then we also had an x plus 2. So x plus 2 had to become part of our common denominator here. So on the left side, we have to multiply by x plus 2 to get our denominator. So we have to multiply the numerator by x plus 2. On the right side, we've already got x plus 2, and what do I need to multiply x by to get x squared? Well, I need to multiply it by x. So now if I expand this, well, 1 times x plus 2 is just x plus 2. Negative x times 1 is just negative x, and this is all over x squared times x plus 2. So x minus x is 0. So I'm left with, as a solution, 2 over x squared times x plus 2. There we go. Now, before we go on with any other examples, lots of people are going to be looking at the first few lessons in this unit and they're going to be asking the question, Mr. Kaminsky, why are we learning this? Like, there is no way I am ever going to use this in life ever. So why am I learning it? Good question. Actually, the use of algebraic fractions, rational expressions, the skills we're developing here with adding, subtracting, multiplying, and dividing, we have to use these when we study a unit in 30-1 called trigonometric functions and trigonometric identities. And all these skills that you're using are going to be used to solve trigonometric type problems. And trigonometry is used a ton in real world situations. So what we're really doing here in 20-1 is we're developing some skills that we are then going to apply to some real world situations in 30-1 in trigonometry. So we got to give you the groundwork first before we can actually give you the real world problem to solve. All right, moving along. If we look at this next example, we already have our denominators in factored form. So the first thing we're going to do is state the restrictions. Well, x plus 1 is going to give us a restriction of -1. X minus 2 is going to give us a restriction of 2. X plus 4 is going to give us a restriction of -4. And we've already done x minus 2. So there's our restrictions. Now, when we come up with a common denominator, the first thing I always do is I go to my first denominator and I write down what I have in that first denominator, x plus 1 and x minus 2. I then go to my second denominator and say, oh, there's an x plus 4. So I need that as part of my denominator. There's an x minus 2. And if I notice, I already have x minus 2 in my denominator, so I do not have to use x minus 2 again. So x plus 1, x minus 2, and x plus 4. Now, if I look at my first denominator and compare it with my common denominator, I have to multiply the numerator by x plus 4. And if I compare my denominator in the second fraction with the denominator I have in the first fraction, I have to multiply my numerator by x plus 1. So now I need to distribute. 5 times x is 5x. 5 times 4 is 20. 2 times x is 2x, and 2 times 1 is 2. Don't forget to multiply by both terms. This is all over our common denominator. Now, 5x plus 2x is 7x. 20 plus 2 is 22. All over x minus 1, or sorry, x plus 1, x minus 2, and x plus 4. Now, you cannot factor this numerator in any way. There's no common factor you can take out. So this is in simplest form, and we did state our restrictions earlier. So there's a few examples. Now, if we look at the next example, we do have to factor this particular denominator. This is a difference of squares. So we end up with p plus 1 and p minus 1 when we factor this denominator. So when I actually go to come up with my non-permissible values here, what will p not equal? Well, p will not equal -1 and +1, and I've already taken care of this one. So we can write p will not equal plus or minus 1. Yes, you can write -1 and +1 separately, but you don't have to. If you now come up with the common denominator, it's going to be p plus 1 and p minus 1. Now, I did not change anything in the first fraction, so this stays as 4. In the second one, I had to multiply the denominator by p minus 1, so I have to multiply the numerator by that. So we're going to end up with 4 plus 2p minus 2 all over p plus 1 and p minus 1. Now, if I combine this, I have a 2p, and 4 minus 2 is positive 2. Now, lots of people will think they're done at this point, but you have to look at this numerator. Remember, we have to try and simplify as much as possible. This particular numerator, what you're going to notice is that we can take out a common factor of 2, and you're left with p plus 1. And we have p plus 1 and p minus 1. Now what you're going to notice is that we have a p plus 1 in the denominator and a p plus 1 in the numerator. So we can simplify these, and we're left with 2 in the numerator, p minus 1 in the denominator. There is our answer in simplest form. If you had stopped at this point here, you were not in simplest form. You had to factor the numerator if possible, and then you had to simplify any binomials or single terms that you could to come up with your final solution of 2p minus 1. Okay, so you always, this is something that's important. They've got it in bold in your book. says we must always check to see that our answer is in fully reduced form. And that's what we did up here. Now, up to this point, all of the examples we've looked at for this lesson have had binomial denominators. The next set of examples are going to have some trinomials in the denominators that we need to factor. Now, before we actually go ahead and actually do some factoring here, what I'm going to tell you is the factoring you use to factor any of these trinomials, you need to do that on a separate sheet of paper. You don't need to show that to me here, but you do need to factor these things out. So if we look at the first example, x plus 1 is already factored. But if we factor the next trinomial, two numbers that multiply to -2 and add to -3, or sorry, two numbers that multiply to -3 and add to -2 are x minus 3 and x plus 1. So now we're going to do our restrictions. What can x not equal? Well, x cannot equal -1, +3. Okay, that's it. We've dealt with all of them because those x plus 1s are the same. Now we're going to come up with a common denominator. Remember, to come up with a common denominator, you look at your first fraction and you write down what you have. Then you look at your second fraction and go, okay, I've already used x plus 1, but I have not used x minus 3. So x plus 1 and x minus 3 are going to be our common denominator. Now, if you notice in this second fraction, we did not change the denominator. So the numerator stays as x minus 1. In the first fraction, we multiplied x plus 1 in the denominator by x minus 3. So whatever we do to the denominator, we have to do to the numerator. And the other thing to remember is that this negative in between our rational expressions applies to everything in that second numerator. So if we start distributing, we get 2x minus 6. This is like having -1 in front. So -1 times x is -x. -1 times -1 is +1. And that's all over x plus 1 and x minus 3. Now if I combine terms, 2x minus x is x. -6 plus 1 is -5. There we have our solution. There's nothing else we can factor. There's nothing else we can simplify. So there's our solution, and we stated our restrictions earlier. In the next example, we have two trinomials that we need to factor. So we're going to need to factor both of these trinomials. So in the first case, we're looking for two numbers that multiply to 2 and add to -3. Well, that's y minus 2 and y minus 1. And if you can't factor this quickly in your head, that's okay. Take out some scrap paper, do your box method factoring. Once you figure out your factors, write them down. Here, two numbers that multiply to -2 and add to 1 are y plus 2 and y minus 1. So if I now do my restrictions, y cannot be 2 or 1. And this second case, y plus 2, means y can't be plus or minus 2. And we've already used y minus 1. So there's our restrictions for this particular question. Now we need to come up with our common denominator. So we have y minus 2, y minus 1, and if I look at the second denominator, I also have a y plus 2. So y minus 2, y minus 1, and y plus 2. So, what did I change in the denominator of the first fraction? I multiplied by y plus 2. What did I change in the denominator of the second fraction? I multiplied by y minus 2. So now if I expand things, 1 times y plus 2 is just y plus 2. 3 times y is 3y, and 3 times -2 is -6. All over y minus 2, y minus 1, and y plus 2. So now if I combine terms, 3y plus y gives me 4y, 2 minus 6 gives me -4, all over y minus 2, y minus 1, and y plus 2. Now we're not quite done. What we can do is we can take out a common factor of 4 in our numerator, which leaves us with 4 times y minus 1. I have y minus 2, y minus 1, and y plus 2 in the denominator. And if you notice in the numerator and denominator, we both have a y minus 1. So those can simplify, leaving me with a final numerator of 4 and a final denominator of y minus 2 and y plus 2. Now, if you remember at the beginning lesson for this unit, I told you that what makes this unit difficult is there's so many steps to solving a problem, and that if you do one step incorrectly, it's going to result in not having a correct solution. And here's a classic example. We had to factor, we had to state restrictions, we had to come up with a common denominator, we had to expand, we had to simplify. There are probably 7 or 8 steps we have to do in solving this particular problem. And if you do one of them wrong, then you're going to end up with an incorrect solution. Something that's really, really important to remember is that if you don't end up with the correct solution, do not erase what you have here, because you can get someone in your group to look at it and see what you might have done wrong. If I look at your work, I can see what you've done wrong. There may be only a couple of things you need to erase and change in this whole thing. But if you erase the whole solution, I can't help you. I can't help identify where you made some errors in the problem. So please do not erase your work, even if you have what you determine to be a wrong solution. Okay, last 2 examples here. What you're going to notice in these last 2 examples is that we have trinomials in the numerator and the denominator. So what we're going to do is we're going to factor the numerators and the denominators before we begin to do anything. So my numerator in the first fraction is going to be x minus 2 and x minus 1. My denominator is going to be x minus 4 and x minus 1. In the second fraction, my numerator is going to be x plus 6 and x plus 4, and in the denominator, it's going to be x plus 6 and x plus 2. Now, since we've factored everything, the next thing we're going to do is we're going to state our restrictions. Well, from the first set of denominators, we'll notice that we cannot have 4 or 1 as a solution. From the second set of denominators, you're going to notice we cannot have negative 6 or negative 2 as a solution. So we have 4 different restrictions. Now before we move on, remember, once you have factored everything, you want to try and simplify. So you're going to notice you have x minus 1s in the numerator and denominator of the first fraction, and you've got x plus 6. You've got x plus 6 that is the same in the second set. So what you're ending up being left with is x minus 2 divided by x minus 4 and x plus 4 divided by x plus 2. So when we go to make our common denominator here, x minus 4 is going to be part of our denominator and x plus 2 is going to be part of our common denominator. Now, if you notice, I multiplied x minus 4 by x plus 2, so I'm going to have to take my numerator and multiply it by x plus 2 on the left side. On the right side, we took x plus 2 and we multiplied it by x minus 4, so I'm going to have to take my numerator of x plus 4 and multiply it by x minus 4. So we also need to remember that that negative is going to apply to everything in the numerator of that second fraction. So we're going to have to deal with that momentarily. So the next thing we're going to do is we're going to expand things. If we expand the numerator here, we're going to get x squared minus 4. If we expand the numerator in the second case, we're going to get x squared minus 16. And that's still all over x minus 4 and x plus 2. So now, if we go x squared minus x squared, we have nothing. If we take negative 4 minus a minus 16, that's actually going to give us 12, all over x minus 4, x plus 2. So there we go. Simplified, and we have the restrictions stated. Now, the last question says, show that this addition actually has negative 7 over a plus 4, a minus 3 as an answer. So basically what they're asking us to do is they're asking us to actually simplify this and get this as a solution. So if we look at our numerators, nothing we can do to factor our numerators, but if we look at our denominators, yes, we can factor our denominators. We have a plus 4 and a plus 3 on the left side. Now, on the right side, we're going to reverse the a squared and the minus 9. We're going to take out a common factor of -1. So if we take out a -1, that's going to give us a squared minus 9. And when we factor that, we get a minus 3 and a plus 3. So now we're going to come up with our common denominator. A plus 4, a plus 3 from our first fraction. We have -1 in our second fraction, and we have a minus 3 that we haven't used in our second fraction. Okay, so now, if I look at my denominator here, I'm going to have to take 2a plus 7, and I'm going to have to multiply it by -1, and I'm going to have to multiply it by a minus 3, and we'll talk about how to do that in a minute. In our second fraction, I'm going to have to take my numerator of 2a, and I'm going to have to multiply it by a plus 4. So if I start expanding here, first thing I'm going to do is I'm going to expand these two binomials first. I'm not going to worry about the -1. So that gives us 2a squared minus a minus 21, and this gives us 2a squared plus 8a. Okay, so now if I apply the negative to all of these terms, that's actually going to change the sign. It's going to make this -2a squared, that positive a, and that positive 21. So that's going to essentially be -1 applying to it. Now -2a squared plus 2a squared cancels out. Positive a plus 8a gives me 9a. And 21, I have nothing to add to 21. So I just have 21 here. So let's just double check some things here. 6. Oh, this should have been plus a to start with here, and so that'll be minus a, which will make this 7. Made a little error there. And we still got -1, a plus 4, a plus 3, and a minus 3. Okay, if we look at our numerator now, we can take out a common factor of 7. And if we take out a common factor of 7, we're left with a plus 3. All over -1, a plus 4, a plus 3, and a minus 3. Now, the a plus 3's can cancel each other out. -1 divides into 7 -7 times, and that leaves me with a plus 4 and a minus 3 in my denominator. There's my answer. Yes, this is exactly the same as what they asked us to come up with.